How many of you have thrown an ender pearl and wasted it, travelling just a few blocks? Well, today I'm going to be using maths and science to optimise throwing ender pearls. So by using this code snippet, I could accurately just throw one ender pearl if I had preset with my mouse the direction. So with angle against distance, I was just going to use a trusty Excel document to record this proof of concept run. Looking at this initial graph data, I can predict it's going to be somewhere around the late 30s with a curve something like that. So now we're going to repeat the same test but with smaller increments to find out the average. For this test I decided to use commands so I could get precisely the right angle, as you can see an F3 there. Instead of just going roughly, this will give me much more accurate results. Here I just time-lapsed the whole process. So now we have our raw data, we're going to turn it into a graph. When I was reviewing footage, I noticed it's probably the slight change in Z causing these anomalies. Future block farms here, it's also the fact that ender pearls have a random element. So I'm going to rerun the test between these 2 points, between 38 and 44, with smaller increments, and see if I can get a better reading, including the Z change, and using X change, not X. So using this more accurate iteration of the command, I'll be able to control it and just make it a bit easier for the data. Again, didn't explain myself that well, because when you teleport it lines you at 0.5, 0.5, this was aligning me now at 0, 0. So with all this raw data condensed into averages, I can tell that there's a negligible amount of difference between 37.5 and 39.5 degrees, and you'll be consistently getting over 50 blocks hopefully in this region. However, that limit of 50 blocks isn't actually a limit, because this whole time you've been watching a standing throw, and there's something that I'll need to test if you add in a jump. As all good scientists do, I made a hypothesis that the best time to throw the ender pearl is right at the start of the jump, as it has the highest momentum with negligible height gain. So we're going to test that out. At the start, in the 1 to 0.6 second delay mark, it shows the ender pearl was thrown pretty much independently of the jump, so we just have the random values showing no real trend. Then at the 0.4 second mark, we have the ender pearl taking the downward momentum, decreasing the value. Then we have one value that's again independent pretty much, because it was thrown at the midpoint, and so that's why we see something pretty in line with these. And then we start to see the increase where it was thrown with the upward momentum, giving it a huge boost up until the maximum consistent average, where here I had to adjust the space timing, and then the highest point mixed with some inconsistencies with it not jumping with that low of a space bar. But yet again I left something out and didn't include sprint jumping. So I quickly made a new program that would test the sprint, and I calibrated my teleport to line me up with 0. Then with this final iteration of code, it would sprint jump forward and release right at the start of the sprint jump to do this, launching me 78.5 blocks. Isn't that phenomenal? As I bet you haven't seen another YouTuber calculating it like this, please drop a like and subscribe, and check out in the description a video where I analyse some other methods with feasibility for launching end.